Section 7.4 is special right triangles. We're going to examine right triangles that have a special relationship. And here's some more practice with simplifying radicals because, again, these are important things during this chapter to be conscious of and keep practicing. If you're struggling, just let me know. But try these 5 questions here. And if you got them correct, these should be the answers. Remember, simplest radical form, you cannot have any perfect squares under the radical, you cannot have any radicals in the denominator, and you cannot have a fraction under the radical. So that's what we're working on it with simplest radical form. So in this section, we are going to use special right triangle relationships to find missing side lengths. So we're going to explore this a little bit. It says find the exact length of the diagonal. So that means we're going to leave it in simplest radical form. Okay, so what we're really trying to find here is the hypotenuse. So if we call it x, then we would find that is we would take 7 squared plus 7 squared and set it equal to x squared. And this gives us 49 and plus 49, which gives us 98. So x squared is equal to 98. So now when we take the square root of each side, we have to do simplest radical form for the square root of 98. Well, 98 is 49 times 2. So when we give them each their own square root, we get x is equal to 7 square root of 2. So this is 7 square root of 2. So let's look at another diagonal of a different square, 5, 5. And we want to find x here. So again, x squared is equal to 5 squared plus 5 squared, or x squared is equal to 25 plus 25, or 50. So when I take the square root, x is equal to the square root of 50. So again, in simplest radical form, that is going to be 25 times 2. So x is equal to 5 root 2. So, any guesses for this last square, 3 by 3? Well, if you guess correctly, what you're going to get for this diagonal right here is you are going to get 3 square root of 2. So, what we are looking at here is a 90-degree angle, a right triangle, and these are 45 and 45. How do we know that? Well, because it's an isosceles triangle, and the base angles theorem says, hey, if you have an isosceles triangle, then the angles across have to be congruent. And so if we've already used up 90 in our 180-degree sum, then that leaves 90 left, divide by 2, and you get 45. So the relationship in 45, 45, 90-degree triangles is we have these two sides are the same. So we're going to call those x. And the hypotenuse is the square root of 2 times x, or the square root of 2 times bigger. So this is our 45, 45, 90-degree triangle theorem. It says in a 45, 45, 90-degree triangle, the hypotenuse is the square root of 2 times as long as each leg, or the square root of 2 times bigger. So we're going to use that to find some missing side lengths. So for example, in this one, again, the converse of the base angles theorem tells you that if those two angles are the same, the sides opposite them are the same. This is an isosceles triangle. So you get 9, 9, and this is going to be the square root of 2 times bigger. So now, again, we know that the hypotenuse is 12 square root of 2, so this would have to be 12 and 12. But what if the hypotenuse isn't something simple, like the last one was 12 square root of 2? Now what? Well, what we know here is we know the relationship is that this side is x, and this side is x, and this is x times the square root of 2. So what we do is we take 12, we know 12 is equal to some value of x times the square root of 2. So we just set that equal to each other. And what we're going to do here is we're just going to solve for x. So to solve for x, I got to divide by the square root of 2 on each side. Okay, so what that leaves me with now is it leaves me with x is equal to 12 over the square root of 2. Well, we can't have a radical on the bottom, not in simplest radical form, so we've got to multiply by the square root of 2 over the square root of 2. So that gives us our value of x is equal to 12 square root of 2 over 2. Well, again, we need to reduce that fraction. So what we end up with our value of x is equal to 6 square root of 2. 6 square root of 2, just like that. Okay? So that's what we're going to do when we find these missing values, is we're going to use that original relationship. And what I do is every single time I write these in here. This is x, and this is x squared root of 2. So now you see, this is very similar to the one we did in example 3. So you see if you can go ahead and find the value of those two x's when we know that 17 is equal to x squared root of 2. So see if you can solve that for x, and then check back to the notes to see if you got it correct. So what if they give us something a little more complicated for x? Well, again, we know this is x, and this is x, and this is going to be x squared root of 2. So again, we can already fill this in. This is going to be 11 square root of 3, because they're the same. So now I have to take this value, 11 square root of 3, and multiply it by the square root of 2. So that's going to give me 11 times the square root of 3 times 2 under the same radical, or 11 square root of 6. So this is our work with radicals that we are again trying to review. And so again, let's have you, well, this one's a little more complicated. I guess I'll work through this one with you. So this is x, and this is x root 2. So again, I'm going to set 10 square root of 3 equal to x square root of 2. And I'm going to solve for x. So I'm going to divide by the square root of 2 on each side. So that gives me 10 square root of 3 over square root of 2 is equal to x. I can't have a radical on the denominator, so I'm going to multiply by the square root of 2 over the square root of 2. So that's going to give me 10 square root of 6 over 2. Again, reducing that fraction right there gives me my x value is equal to 5 square root of 6. All right. So let's move on to another special right triangle, an equilateral triangle. So in an equilateral triangle, we know that all the angles are 60 degrees. And when we find the exact height here, what we're going to be doing is we are going to find this height, which is going to be a 90-degree angle. And remember that that height is also the median, so it cuts this in half. And it's also the perpendicular bisector, and it's also the angle bisector, so it bisects these angles. So when we look at those, we can find that using the Pythagorean theorem again. So if we are finding this exact height right here that we're trying to find, again, I'm just going to call it x, then we are going to use the fact that we have a right triangle with legs 5 and x. I'm going to set it equal to the hypotenuse squared. So this gives us x squared equals 75, and 75, when we take the square root, is 25 times 3, so x is the square root of 25 times 3, or x is equal to 5 root 3. So x is equal to 5 root 3. And if we do the same thing with this one over here, again, we're finding the exact height, which makes this 4, and it makes this, we'll call it x again. So we can do 4 squared plus x squared equals 8 squared. So x squared equals 48. So x is equal to the square root of 48, which can be broken down into 16 times 3. So x is equal to 4 square root of 3. So, are you seeing, we are looking at this 30, 60, 90 triangle, and are you seeing any relationship? Well, hopefully you're starting to notice that in this triangle that we just got done finding the height, remember this came from the equilateral, so it's half of the equilateral triangle, and so we have this 30, 60, 90. And remember, if we call this side x, this side was actually twice that. And this height was actually the square root of 3 times bigger than our shortest side. And that's our relationship in 30, 60, 90 degree triangles. We have x, and then the hypotenuse is 2x, and the longer leg is the square root of 3 times bigger than the shorter leg. So that's our 30, 60, 90 triangle theorem. It says in a 30, 60, 90 degree triangle, the hypotenuse is twice as long as the shorter leg, and the longer leg is the square root of 3 times as long as the shorter leg, or bigger than that. So that's the relationship we're going to use now to find some missing values. So again, what I like to do is I like to write the relationship. The shorter side is x, the hypotenuse is twice x, and the longer leg is x times the square root of 3. So if this is 5, the hypotenuse is 10, and the longer leg would be 5 root 3. So that's just the basic ratio. So now if we work backwards here, again, this is x, this is 2x, and this is x root 3. So if 2 times x is 20, then x has to be 10. You could set that equal to, you could set 20 equal to 2x to find x, but most of you probably can do it intuitively. And so that means the longer leg is the square root of 3 times the short leg, so it's going to be 10 square root of 3. Oh, sorry. Yes, that is correct. All right, moving on. So what if the triangle's tipped? Well, you still have to figure out that the shorter leg is always directly across from that 30-degree angle. So this is going to be your x, and this is your hypotenuse, twice x, and this is going to be x root 3. So if x root 3 is equal to 4 root 3, it's pretty obvious to see that x is 4. And then our hypotenuse would be 8. But again, they sometimes get more complicated because now what if the longer leg is equal to 8? Again, our relationships are x, 2x for the hypotenuse, and x root 3. So I'm going to do the same thing I did with the 45, 45, 90s. I'm going to take the 8 and set it equal to x square root of 3. So now to solve this, just like I did before when I solved for x, divide by that square root of 3. So now I get 8 times 8 divided by the square root of 3 is equal to x. Again, I can't leave it like that. I have to multiply to get rid of that radical on the denominator. So I get 8 square root of 3 over 3. That's what my value of x is. So 8 square root of 3 divided by 3. Now to get I have to multiply this by 2. So that's going to give me, when I take 8 square root of 3 over 3 and I multiply it by 2 over 1, I'm just multiplying the 8 and the 2, so it's going to give me 16 square root of 3 over 3. Okay, now this time we're given the hypotenuse, and it's a radical. So again, going back to those relationships, shorter leg is x, hypotenuse is 2x, longer leg is x root 3. So I know that 6 square root of 3 is equal to 2 times x. So if I solve this for x, and again, you could do this intuitively, I'm going to divide by 2, and what that's going to give me is 3 square root of 3. So 3 square root of 3 is my x. Now I need to take my value of x, so 3 square root of 3, and multiply it by the square root of 3. That's what's going to give me the longer side. Well, this is going to be 3 times the square root of 3 times the square root of 3, which is the square root of 9, which is 3. So you get 3 times 3, which is 9. Okay, one more example here. We'll let you practice on your own. So here we have, again, shorter leg, hypotenuse, longer leg. So if our x value is 8 root 2, then 2 times that would be 16 square root of 2. And if I take 8 square root of 2 and I multiply it by the square root of 3, that's going to give me 8 square root of 6. And that is the end of